Hello, welcome to Hayward's Maths. Today I'm doing geometric proofs with vectors. If you want to skip ahead, go to one of these times shown on the right. The most important steps in doing geometric proofs is to draw a picture, label your variables, and think about the shapes in your proof. So if it's a rhombus, think about the properties of the rhombus. So let's draw the rhombus. Rhombus O, A, B, C. We know a rhombus has what? 4 equal sides. So these lines tell us those 4 sides are equal. I'm just drawing them out of the way. We also know we have 2 sets of parallel sides. Okay, now this is a geometric vector proof. So like I said, label it with lowercase a vector going from O to A. So going from O to A is equal to lowercase a. It is also equal to what?
C to B.
Good job, guys. Yep, vector C to B. Okay. We also have vector lowercase c, which goes from here to here. So vector OC is equal to lowercase c, which is equal to vector A to B. Okay? A vector is the same vector if it's the same length and the same direction. So because they're parallel and then the same length, because it's a rhombus, yeah, they're the same vector. On this side, OC is the same as AB. Correct. Good observation. Yes. So because it's a rhombus, the magnitude A is equal to magnitude C. So all of these magnitudes are equal because it's a rhombus. So first step, draw a diagram, label it with O, B, C, D if you need, or E or F, etc. Use the lowercase a, c if it's required, lowercase b if it's 3D, or you can use whatever lowercase letters you want. I used lowercase a because it's going towards point A. Does that make sense? But you can literally use whatever lowercase you want. Then you have to think about what properties do I know about this shape? I know it's a rhombus, they have equal sides, so all of the sides' magnitudes are equal. Because we're doing vectors, you have to think about the magnitude, the length of the sides. So the question says, we've got a rhombus, there's points P, Q, R, S, which are the midpoints in the rhombus. P, Q, R, and S. And it forms a shape. It says, prove that the shape that's connected by those 4 midpoints is a rectangle. Now, do you remember the last example on Friday? What happened when it was a rectangle? So when we do the dot product of 2 sides, so PQ dot with PS, this is 0. Yep, so we put from Q point to R point as a vector in terms of little a and little c, yeah? Because we want to show that QR is equal to PS. You can start with whichever one you want. You just want to show... I see what you're saying. Okay. Well, let's just do all 4 sides. So what's PS in terms of A and C?
Half A plus half C.
Yep. So half of A, because it's going positive A, and half of C, it's going positive C direction. Perfect. All right. Now let's try QR.
Same QR.
QR is the same. What about PQ? This is what we want to get to. So these are the 2 we want in terms of A and C.
Would it be half negative A plus half C?
From P to Q, yep. So negative half A plus half C. So it's gone negative A direction and then plus C direction. Is there any questions so far? So I'm thinking about what is a rectangle? Rectangles have 2 equal sides and then 2 other equal sides. So I'm thinking, okay, let's get those sides in terms of A and C, and then let's try and dot product those sides to see if it works. No, the magnitude of A and C are equal. Yeah, because they're going in different direction. A and C are not equal. Yeah. So you've got to keep this in mind when we do this. Okay. So there's a lot to this. I'm trying to break it down so you guys are kind of understanding. So if you do a similar proof, you kind of at least have some ideas. Is this kind of helping? Okay. So now we've got the 4 sides of this apparent rectangle. We don't know it's a rectangle. So let's try and see if it's a rectangle by doing the dot product. Okay, so we're going to do the dot product of PQ. I'm going to put the C first. So I've substituted in PQ, and that's going to dot with PS. Okay, I'm going to now expand this. So half C dot with half A becomes a quarter C dot A. Next one, half C dot a half C. Now what did I say happens when you dot product the same vector? If this is C and we're dot producting a vector in the same direction and the same magnitude, the angle between it is 0. So you just end up with, because this is the formula, cos and the angle between them is 0. And you guys remember cos 0 is? So we end up with the magnitude squared. Does anyone not get that? So if you ever dot product vector by itself, it just becomes the magnitude squared.
Because what you're doing, are you just using the dot product as like a normal times thing?
Yeah. So like
So
this
B and A are
this
like
foil process I'm doing. So you know this dot product when it's in polar, this is when it's in Cartesian.
So the A and C are like I and J.
Yeah, pretty much, yeah.
But they're not. Dot in your answer because you have C by A, so it's not like you've got rid of the dot.
I haven't got rid of the dot.
Like it's still the dot.
I expanded the dot product. Because the vector contains two vectors within the vector.
It hasn't actually performed the dot.
Does that help? No? Still confused? Yeah. I can't think of any other way of explaining it apart from you're allowed to expand the dot product like this. So this bit eliminates by this bit.
And then do the magnitudes eliminate because we've already specified this.
And this bit eliminates this bit because we already specified this. Sorry, I'll zoom in. You're okay?
Yeah.
You're okay? Yeah? So what's the final result? 0. And what does the 0 tell us? So remember we wanted to get to this. Did we get to it? Yeah. Okay. So then we would finish with the statement. If the dot product, then the angle between is what?
90.
Perfect. And therefore the PQRS is a rectangle. Because we showed two sides were equal, two other sides were equal, and we also showed it is perpendicular. Yes, because if the two sides were equal, two other sides were equal, but it wasn't perpendicular, what shape is it?
Parallelogram.
Yeah, it's a parallelogram. Yeah.
Yes.
The question to it's the same question, right? If the parallelogram is a rectangle,
So it says if the diagonals, remember what the if means? So you assume AC is perpendicular to OB. So the dot product of those two should equal 0. This is what you're trying to get towards. So again, you make the sides equal to A and C lowercase, those vectors. AB equals A plus C. Yep. Oh, yeah. Sorry, I always start at that point and go that way. And you said C. Oh, you just went the other way. That's why I got confused. Okay. So I guess now we could just try dot producting, see what happens. I feel like this is too easy. Did anyone do it this way? So remember the dot product of a vector by itself?
different perfect squares?
No. Because A dot C is not necessarily the same as C dot A. I don't know, prove it to me, Julius.
I think my first successful proof though. Question 3.
Okay. So that one was a little bit easier, I suppose. I don't know. Did other people do it like that?
Does it show that
There's-
equal?
I don't know. Does it show it?
I don't know.
Well,
But
it's
we've already been told that though.
But A dot C can't be the same as C dot A in something. So you can't do that. That's what you're logic.
Yeah, why is it not saying plus not equal to 0?
You just,
Accept it.
they are the same, but you can't do the perfect squares.
What happened to A squared plus C squared?
So I think negative.
Ah, okay.
Oh, wait, it doesn't work.
Yeah, does it negative a squared?
It's meant to be negative A squared.
But the magnitude of A is
If we need to specify that, you know,
So if the other people have zoned out, perpendicular dot product is 0. Right? So I expanded the dot product. I then can bring the A and C so they're equal to each other on both sides of the equal sign. Because it's equal to 0. And because they're equal, it shows it's a rhombus.
Sometimes you just have to accept.
Express LM in terms of L, M or N. So LM, what is LM in terms of L, lowercase l, lowercase m, lowercase n? Anyone know? From L to M. So to get from L to M, we're going in the M direction and we're minusing L.
so that's a signal.
We can go O and take O L. And,
Let's do it this way. From L to M is OM minus OL, which equals M minus L. Does that make sense? Right, I'll do one more. MN. MN. Any ideas, Levi? Still writing, sorry. You're just trying to put them in terms of other letters. You're not trying to prove anything.
Would MN be ON? Which would be
Does everyone see that?
Also be N minus L.
So to get from M, I'll draw a different color. To get from M to N, you can go positive ON or minus OM plus ON. I'll probably do it that way. I feel like that makes more sense. To go from M, at least CC is listening. To go from M, you go from M to O, so that's negative OM, yeah, CC? and then you go positive ON. So you go from the letter following, yeah? Does that make sense, Levi? To go from M to N, you can go OM and then ON. Yeah? Minus. Alright, what about an expression for the line joining the midpoints of OL to LN?
We didn't use any terms for
Plus n to n, it's all about minus n plus n.
I think it's easy to go minus L. So minus L, N. So I always follow the actual paths of the lowercase. Does that make sense?
Why is the L negative?
Because you're going back that way and then up that way to go from L to N. In this bit, yeah? So it ends up being just half N. So I'm going from this spot to there. Yeah? So to go, I go half L that way. And then if I want to get up there, I can go a whole L plus half an N. This will make more sense, hopefully. I'm going, see the length OL? So I'm going half OL plus half LN. Does that make sense? So half of OL is a half L. Yeah? Half LN is a whole, or LN is equal to LO plus ON. And that's equal to yeah?
You could also do LN equals ON, take OL.
Yeah.
It's hard to visualize it.
That might be, maybe that's better to visualize. There's lots of ways to do this.